Hi there, my name is Shelley. This is the fourth lesson on algebraic fractions. And so far we have revised the factorization of expressions and we've learned how to simplify fractions. By the end of this lesson, you should be able to simplify expressions that include the difference of squares. To begin this lesson, we will look at what we mean by the difference of two squares. And let's show you now with an example. Look at a squared. It is a perfect square. It is a times a. And b squared is a perfect square. It is b times b. If we have a squared minus b squared, the minus sign implies a difference between the two terms. So a squared minus b squared is called the difference of two squares. Now, in order for you to understand how to solve the difference of two squares, I want you to look at the following process. How do you multiply a plus b by a minus b? Well, a multiplied by a is going to give us a squared. And a multiplied by minus b is going to give us minus ab. Then b multiplied by a is going to give us plus ab, and b multiplied by minus b is going to give us minus b squared. So if you add your like terms, you will get a squared minus b squared. So multiplying a plus b by a minus b, we get a squared minus b squared. Do you see we are back where we started? We have a difference of two squares. And we got there through the process of multiplication. Now if we reverse this process of multiplication and factorize a squared minus b squared, all we need to do is take the square root of each term. So we start off putting down our two brackets. And we know the one is going to have a plus sign in it and the one is going to have a minus sign. And then we need to square root the first term. So a squared square rooted would give us a. And that goes in the first place in each bracket. And then we square root the b squared and we are left with a b. And that is how we factorize a difference of two squares. Here in the one bracket, we have the sum of the square roots. Here a and b are added. And in the other bracket, we have the difference of the square roots. Here a and b are subtracted. The minus sign means difference. So from this, we can see that we can factorize the difference of two squares. So now let's try and factorize a few more of these type of expressions. Here is the first one, x squared minus y squared. It is the difference of two squares. So let's factorize. We know straight away we put down our two brackets. And we know inside the brackets we're going to have one with a plus sign and one with a minus sign. Now we need to find the square root of x squared, and that is x, and that goes in the first place in each bracket. And then we find the square root of y squared, which is y, and that goes in the second place in each bracket. And we have now factorized. Here is the second one. Let's factorize it. 16a to the power of 4 minus c to the power of 4. Now how do we do this one? Well, it's the same. So we first put down our two brackets, and then we put down a plus sign in the one and a minus sign in the other. Now we need to find the square root of 16a to the 4. First of all, the square root of 16 is 4 because 4 times 4 is 16. So we can put down a 4 in both places. Now the square root of a to the power of 4 is a squared because a squared times a squared gives us a to the power of 4. So we put that down in the first place, a squared and an a squared. Now we move on to our second term, c to the power of 4, the square root of this would give us c squared, and we write that down. Good, but are we finished? Look again. Look carefully at the second bracket. This is the difference of two squares again. So this bracket can still be factorized further. And the first bracket? This is the sum of two squares. Can the sum of two squares be factorized? Think about it. It is not possible to write the sum of two squares as a product. In other words, that bracket cannot be factorized. But let's do what we can and factorize the difference of two squares. Now we can't do anything further with this bracket, so we can just rewrite it. So we write 4a squared plus c squared. Now here is our difference of two squares. So straight away we put down our two brackets, and we know we're going to have one with a plus sign and one with a minus sign. Now we need to find the square root of 4a squared, and we should know that that gives us 2a, and we write that in the first place in each bracket. And then the square root of c squared, which is c, and we write that in the second place in each bracket. And this is our expression fully factorized. So far in our lessons on algebraic fractions, we have learned to simplify fractions, and we learned that we can only cancel if we have factors. And that's why we've been practicing how to factorize. Right now we've just learned how to factorize the difference of two squares. So let's move on to tackle some fractions. Can you simplify this fraction? A squared minus 9 divided by a plus 3. Well, can you cancel these, a into a squared? It's tempting to want to cancel a into a squared, but they are terms. Notice the minus sign and the plus sign, and we can only cancel factors. So, what do? Can you factorize the numerator? Yes, it's the difference of two squares. So we can write it as, remember we put our two brackets down, a plus sign and a minus sign, and we find the square root of each of these. So we're going to get a plus 3 multiplied by a minus 3. And that is all divided by a plus 3. Now, what do we do with the denominator? Again, we can only cancel factors. So I put brackets around the terms in the denominator. And now I can cancel because I have factors. So we cancel our common factors, and we are left with a minus 3. And this is the fraction simplified. Let's try another one together. Just concentrate and follow the steps we've learned. Simplify p squared minus 36q squared divided by 2p squared plus 12pq. What can we do with the numerator? We can see it is the difference of two squares. So we factorize it by finding the square roots. So let's put down our two brackets. Once again, we put a plus sign down and a minus sign. Then we find the square root of p squared, which is p, and we put it in the first place in each bracket. Then the square root of 36q squared would give us 6q, and we put that in the second place in each bracket. Now the denominator. It has two terms. So we cannot cancel. We need to factorize it. Do you remember how to work with a common factor? We can see that 2 is a common factor. It divides into both terms, so we can write it down. But is that the only common factor? Notice the p is in each term as well, so it's also a common factor. So we can write 2p rather. Now we've got to factorize. So we say 2p divided into our first term, what are we left with? We're left with a p. Plus 2p into our second term, what are we left with? We are left with 6q. Now we're going to look for our common factors. Notice p plus 6q and p plus 6q at the bottom are common, and we can cancel them out. So we cancel, and what we are left with is p minus 6q all over divided by 2p. And that is our final answer. Always be on the lookout for the difference of two squares when you need to factorize. The first thing you need to look for is a minus sign between the two terms. Then you need to see that the two terms are perfect squares. In other words, that you can find the square root of each of them. Now remember, you might have to take out a common factor first before you recognize a difference of two squares. Anyway, here's a task for you to try on your own. Simplify 16 minus 4k squared, all divided by 4k plus 8. Remember to join me for the next lesson, where we will continue to work with the more advanced fractions, and we will learn to simplify expressions which include trinomials.